Review Unit 2A. This is just review number 1, not review number 2. All right, number 1, we're going to match up corresponding sides and solve for x. So I've got the 2x minus 10 corresponds with the 24 over here, and the 6 up here corresponds with the 36 over there. So matching up corresponding sides here. And I am going to cross multiply and solve. So this would be 36 times 2x minus 10 equals 6 times 24. Who designed this with no room to work? Got to distribute over here. That would be 72x minus 360. And 6 times 24 is 144, maybe? Is that right? 144? 6 times 20, 120. I think that's right. And then we're going to add the 360 over. So let's add the 360 over to the other side and get 504, I believe. So 72x equals 504 when we add the 360 over. Divide by 72 on both sides. Is that going to be maybe 7? Maybe it's 7. You got a calculator, do your best. Next one, I've got 18 over here, matches up with x plus 1 over here. And 12 matches up with 8 over here. How about you push pause, try to solve this really quickly. Make sure you can cross multiply for this test. When I cross multiply, I'll have 12 times x plus 1 equals 8 times 18. And next step is I'm going to have to distribute. So I'm going to distribute and get 12x plus 12 equals 18 times 8, I think is 144. I didn't put an x right there. I'm going to subtract the 12 over, get 12x equals 130, not 6, 132. And then I think x equals 11. Okay. Next, you're going to need to know your definitions and diagrams of all the quadrilaterals. So if I'm looking at, let's look at the pictures first. This one's a rhombus. All 4 sides are equal. No right angles in there, so it's just a rhombus, not a square. This one's a kite. Number 3 over here, 4 congruent sides and 4 right angles. Something with 4 congruent sides and 4 right angles, that's a square. Contains exactly 1 set of parallel lines. Well, a parallelogram has 2 sets of parallel lines, but just 1 set of parallel lines would be a trapezoid. Okay. Number 7 down here, I am trying to solve for x, and I have a parallelogram. If it doesn't say that, but let's assume this thing's a parallelogram. And my next question is, are these opposite or adjacent angles? Are they opposite? So U and S would be opposite, T and V would be opposite. Or are they adjacent, meaning right next door to each other? They look like they're right next door to each other. So when they are adjacent angles in a parallelogram, they are supplementary, meaning they add together to give you 180. So 180 equals 18x minus 4 plus 76. Gonna combine my like terms over here and get 18x plus 72. Subtract the 72 over and get, I don't know, maybe like 108. Divide by 18 on both sides and you would get 6, I believe. X equals 6. Number 8, we have another quadrilateral. It's a kite. So in a kite, there's 1 set of angles that are congruent. that would be these right here, the 107 and the x. So that's the easy one. And if this is 107, then we can solve for y. We know that the total degrees in a quadrilateral is 360. So I can take all these, add them up, and equal 360. So push pause, see if you can do that real quick. 360 equals all those added together, and then unpause it. 360 equals y plus 107 plus 107 plus 76. That would be y plus 214 plus 76, I think is 290. 214, yeah. Subtract the 290 over, you get 70. So y equals 70 degrees. Okay. Number 9 over here is a little bit different problem. It's a parallelogram, so that's good. And we're just going to use the fact that at some point in your life you talked about alternate interior angles, whether that was the 7th, 8th grade. So I know that 18 and y are the same thing because those are alternate interior angles. So I'm going to put 18 down here. And then I have another set of alternate interior angles up there, which would be x and 27. So that means that's 27 and that's 18. And then what I do is I make this triangle up here, I kind of cut the top half off. And I say I have a triangle up there, and I know how many degrees are in a triangle. How many degrees are in a triangle? 180. So I can take this angle, those angles, and that angle and add them together to give me 180. Okay, so I'm going to write this down here. 180 equals 27 plus z plus 55 plus 18. And all that's going to give me 180. I got a triangle up there. Okay, so I got 180 equals whatever that is. I don't know. 27 and 18 is 45. Maybe 90. That doesn't look like a right angle, but subtract that over, you get z equals 90. Okay. The next one I got an isosceles trapezoid. You know, normally we look at them like this, but it just got rotated. Looks like 90 degrees. And if I look at x is really easy. It's 65. And then there's a couple different ways of going about this. We've said that the angles in between the parallel lines are equal to 180. So these would be equal and these would be equal, but the ones, you know, on the opposite sides of these parallel lines are going to add to give me 180. So I'm going to say 180 equals 2y plus 5 plus 65. That's 180 equals 2y plus 70. Subtract the 70 over, you get 110. Divide by 2, y equals 55. That's not my answer though, because it wants the measure of angle n. So I'm going to take y and plug it in up here. So I'm going to write up here. Angle n equals 2y plus 5. Angle n equals 2 times, I got 55 for y. And angle n should equal 115 maybe? All right, let's graph this thing. So I have the following points. Let's graph these. 0, -3. That is A. B is at -3, 1 right here. And C is at 2, 2 right here. So I have a triangle. And I have a scale factor of 3. So we're going to dilate this thing by a scale factor of 3. And when it's just from the origin, it doesn't say from the origin, so let's write that. From the origin. When we're dilating from the origin, we just write the rule. 3x, 3y. So I can take each of these, plug them in for the formula. So this would be 0, negative 9 down here. That would be A prime. Negative 3, 1 would be negative 9, 3. And then 2, 2 would be 6, 6. So this is what your new triangle should look like. Okay. Next one, we're not dilating from the origin. We're dilating from another point. This is a 3-step process. Step number 1, going to subtract the center. Step number 2, going to apply the rule. Step number 3, going to add the center back. I want you to push pause and try this on your own real quick, please. So step number 1, going to subtract the center. I've got 4, negative 9 minus 0, negative 3. That would be 4, negative 6. Step number 2, I'm going to bring that up here and apply the rule. This is ugly. So the rule is 1/4 x, 1/4 y. So 4 times 1/4, that's just 1. Negative 6 times 1/4, when you punch it in your calculator, that would be negative 3/2. And then I'm going to take that for step number 3, 1, negative 3/2, and add the center back. That's 0, negative 3. So if you add that, that's real easy, 1. If you punch this in your calculator, that's negative 6/2. I think it's negative 9/2. Okay, let's look at this one. Triangle FGH was reflected across the x-axis. So we're looking at FGH right here. Was reflected across the x-axis. Now it would be like down here, okay? And then this was reflected over the y-axis to make this thing. Which statement is true? The figures are both similar and congruent. They're neither similar nor congruent. Similar but not congruent. Congruent but not similar. Well, congruent means everything about them is the same. Are all the angles the same? Are all the sides the same? Similar means they're the same shape, but not necessarily the same size. They could be the same size if you had a scale factor of 1. So, are these congruent? Yeah, they're the same triangle. It's just flipped over. Are they similar? Yeah, they are. They're the same shape. Both of them. They are both similar and congruent. Number 14. In the triangle shown, triangle ABC is dilated by a factor of 2/3 to form triangle XYZ. So this one has been multiplied by 2/3 to get to over here. Angle A is equal to 38 degrees. B is equal to 102. What is the measure of angle Z? You know, it'd be really nice and easy if it said, what's the measure of angle C? But it doesn't. A trap that people fall into is that they try to multiply 38 by 2/3 and 102 by 2/3. That is incorrect. Because we know that when you dilate things, they are similar. And in similar figures, corresponding angles are congruent. So we dilated this one to make this one. Therefore, these are similar. Therefore, all their angles are the same. So if A is 38, then the one that matches up with it over here is 38. B is 102, the one that matches up with it over here is 102. So that makes it easy to solve for Z. There's 180 degrees in a triangle, so I got Z plus 38 plus 102 equals 108. That'd be 180 equals Z plus 140. Bring that over, Z equals 40 degrees. Okay? 15, which of the following algebraic expressions represents the total angle measure in the kite? Push pause. I want you to try this one real quick, please. Combine your like terms. So 360 total degrees in any quadrilateral, you know, this kite quadrilateral, that was a dead giveaway, all the 360s here, equals all these angles added together. I got x plus 118 plus x plus 34. So when I combine like terms over here, I got x plus x is 2x, and 118 plus 34 is 152. There's an option right there, B. That says the same thing. Okay. Let's go down here, solve for x. So on 16, we said that we could set up a proportion and say several different ways you could do this. I think that we did it as 12 is to 9. So this side matches up with this side over here. And then 4 matches up over here with x. That would be 12x equals 4 times 9. 4 times 9 is 36. Divide by 12, x equals 3. Number 17 is very similar, except you're going to set up proportion and reduce the fractions or cross multiply. And if you get things are equal, then these lines are parallel. BD is parallel to AE. If you get they're not equal, then those lines are not parallel. Okay, so push pause, make a proportion, see if they're equal to each other. Okay, so I'm going to match up 16 is to 14, just like we did over there. And then 12 is to 9. 16 over 14 would reduce to, I can punch this in my calculator and push the magic arrows. So push the N over D button, make the fraction, and then push the magic arrows. It'll reduce it for you. I think that would be 8 over 7. This will reduce to 4 over 3. Those are not equal. Therefore, BD is not parallel to AE. Okay. Now let's look up here. Number 18. I got the angle criterion, so I'm just trying to prove that these things are similar by showing they got all the same angles. So I think we put an x right there and we put a y over here, and we made two equations. We said 180 equals x plus 47 plus 32. And then we said 180 equals 32 plus 101 plus y. And then we solved them. How about you push pause right now? Solve them. See if you get the same thing. (180) equals x plus 79. Subtract that over, you get x equals 101. That looks good. And then over here you get 180 equals 133. Is that right? Plus y. Is that right? And then subtract that over, y equals 67. Man, what did I do wrong? It's not 67. That's what? Duh. 47. Yeah, 47 is right. That's good, because those are the same. So, yes. Triangles are similar because all of the angles are the same. Okay, number 19, we're going to set up proportions. And we're going to say this fraction equals this fraction equals this fraction. And when we reduce them, if we get 5 equals 5 equals 5, then these triangles are similar. If we reduce them and we get 5 equals 2/3, not similar. Okay, so how about you push pause? Try to see if these are similar or not. (33) over here matches up with 22 over there. 75 is the next biggest side over here. 50 is the next biggest side over there. 90 is the biggest side over there. And the biggest side over here is 90. That would be 3 over 2 equals 3 over 2 equals 3 over 2. You could have started over here and had 2/3 equals 2/3 equals 2/3. All that means the same thing. So since they are all equal, yes, triangles are similar. Remember on your tests, on your next review sheet, if you get, 3 over 2 equals 3 over 2 equals 3 over 4, then they are not similar. Okay. Last set right here. What transformations or series of transformations maps triangle ABC onto triangle AEF? Well, I got ABC right here. This is the one I'm starting with, and I need to map it over here onto AEF. So first thing I'm noticing is I'm going to reflect over the y-axis. And when I do that, it's going to be right here. And then I'm going to need to dilate. I'm going to need to multiply by, so let's say dilate by a scale factor of k equals 2. How do I know it was 2? Well, a couple different ways. 1, 2. 1, 2, 3, 4 on my new triangle. So that means I multiplied by 2. The other way is this one's 1, 2, 3 tall, and then the big triangle is 1, 2, 3, 4, 5, 6 tall. So I multiplied by 2. So I dilated by a scale factor of 2. From this point, it's important, from 0, 3. Okay? Explain why angle ABC is congruent to angle AEF and why angle ACB is congruent to AFE. So we want to know why ABC, this angle right here, is congruent to this angle right here, and why this angle is congruent to that angle. Well, if we dilated, so we know they're similar figures, and we know that in similar figures, corresponding angles are congruent. So in similar figures, corresponding angles are congruent.